Start recording. So your first step is to figure out what parent table you're working with. And then after you figure that out, the transformations you apply will always be the same. It's always h plus x, y times a plus k. Okay? The only time we don't do this is for a constant function or for a linear function. Everything else, we're going to do a table and apply our transformations that way. So after you did that, when we create our table, this is for our new function. I'll do it in blue. So this is what you're graphing. So when you added the -1, your x value should have all just went down 1. And then for your y values, you have to multiply it by -3 and add -2. So for the first one, that would be what, -14?
Yeah.
The good thing about a quadratic is that the numbers repeat, so you just kind of. And then we have -3 minus 2, which would be a -5. And then -2. So check and make sure that that is correct. Is that what your table look like? Because that's the table we're going to graph. So now, if you don't have graph paper, just make a x and y coordinate plane and do the best you can. But let's go ahead and graph this out. And because I realized that my y values are all negative, I'm going to kind of create my coordinate plane so that it's bottom heavy. All right, I don't know. Let me see. 1, 2, 3, 4, 5. Okay, I got enough. So -14. Got at 1. And -3 is 0. We're at -5. So 1, 2, 3, 4, 5. And then we have a point at -1, -2. And then we have a point at -2, -5. So this is what our graph should look like. Just like so. Yeah, I believe so. But that's just something good to understand and know, because I can tell you that that's one of the things you do in college algebra. Transformations never go away, ever. Okay, so last thing is let's describe our domain and range. So our domain, I'm trying to figure out where to write it. Okay, I guess I'll just write it right here. Domain should be pretty easy. Looking at your pink sheet, what does it say for every quadratic? Your domain is what? -infinity to infinity. Because look, if you look at this graph, notice that this graph is going left and right. So because it's going left and right, we know our domain is all real numbers. But the range, that's different. So for your range, when we look at this table, the highest number it comes to is -2. But all the other numbers are less than -2. So your range would be from -infinity, because you always start with the smallest number. And the smallest number in the world is -infinity. If you have arrows going down, your range will begin with -infinity. So -infinity until what? What's the highest number? -2, excuse me, -2 would get a bracket. So that would be it. So we're only graphing today. Just graphing, applying transformations, graphing. So you look at your pink paper, determine what your parent table is, and then you apply your transformation. Does anybody need more time to copy this first one down? Can we move on to our second one? Okay. So question number 2, let's go ahead and graph. G of x equals 1/2 times x minus 1 cubed minus 2. Looking at your pink sheet, identify A, H, and K. For a cube function. So what is A? 1/2. So what is that going to make the graph do? Not stretch, but what? Compress. What about the H value? What's the H value? Is it positive 1 or negative 1? Positive 1, which means it's going to do what? Move to the right. And what's K? And what's that going to make it do? All right. Let's go ahead and get your parent table from your pink sheet. So now we're cubing each number. And now you just apply your transformations. That's your parent table. Go ahead and add H to X. Multiply Y by A. And then add K. So take a minute. All right, so I didn't use a calculator, so you might want to verify my blue table is the correct table. Is that what you all got? Yeah. All right, good. My mental math is working this morning. This graph, if you look at the parent, looks like a, I don't know, it's like a a squiggle, I guess. I don't know how to explain it. It's a line with a little dip in it. That's what your graph should look like. But I don't want you to just copy what I am doing. I want you to understand, like, I get you started, you should be able to finish it. And if you have a question, this is a great time to ask a question. Because, like I said, we moved the test back, so we got time.
So the -2, the -1, 0, 1, 2, is that, can we use that for what, every function?
So you have to identify what kind of function it is. This has an exponent of 3. So you need, you mean the -2 and +2 for x?
Yeah.
You can use that for anything except for a square root, because you can't take the square root of a negative. So for the square root, I'm very particular in the numbers. Now, a cubic function, because if you look at your x, even if you look at your table, looking at the table and looking at the graph, notice that this graph has an arrow that's pointing left and an arrow that points right. If you look at these x values, you have negative and positive. So that tells me that my domain is going to include all kinds of numbers. And the same thing with your range. Your range has negative and positive. It's pointing up and down, so your range. And if you want to add to your pink sheet, every odd degree function has a domain of all real numbers. So the linear function that we looked at, that's always going to have that domain. And the cubic function is always going to have. The only thing that does not have a domain of all real numbers is what? What's the only function that we talked about yesterday that did not have a domain of all real numbers? A square root. Everything else, all real numbers. Okay, let's do our next graph. Number 3, h of x equals 2 times the absolute value of x minus 3 minus 5. So again, you're going to identify a, h, and k. State your transformations. And then determine which parent table we're looking at now. What kind of function are we graphing? This is a what kind of function? Absolute value. So that's the parent table. So I'm going to give you a couple of minutes to try and graph it all by yourself, and then you can compare your answer. If you look at the pink sheet, it has above each graph the transformation form and what each transformation, where it's located. So A is always in front of the absolute value, or it's in front of the square root, or it's in front of the parentheses. That's A. H is always inside, and you have to flip the sign. K is -5. So because A is 2, that's going to make it do what? Is it going to stretch or compress? Hello? Anybody? Stretch. H is 3. Is that going to make it go up, down, left, or right? Right 3. K is -5, so it's going to go down 5. All right, so let's do our transformations. I'm going to make a double table for this one, like we used to do back in Algebra 2. So for absolute value, you're taking the absolute value. A lot of students get, just remembering from last year's test, a quadratic and an absolute value, they look similar, but they're not the same. Okay, so your parent table is different. When you square a number, that's called a parabola. It has a bend at the bottom. An absolute value looks like a letter V. It should be pointed at the bottom. Okay, so this is my transformations. Now I'm going to add the 3. Go ahead and add 3 all the way down. So when I add 3, you should have 1, 2, 3, 4, 5. That's always easy to do. And then your y values, you're multiplying them by 2 and then adding a -5. So 2 times 2 is 4. 4 minus 5 is -1. So that would be a -1. 1 times 2 is 2. 2 minus 5 is -3. -5, -3. All right. Who had that? This is my table right here that I have. This is what I'm graphing. Who had that as their table? All right, let's go ahead and graph it out. So when we graph it out, we have 1, -1, 2, down 3. Absolute values are easy to graph because it's just the slope. So that A value is really your slope. So I know I'm going up to the right one. So that should be what your graph should look like. It's a little skinnier than the parent, which is why we say it's stretched. It moved to the right 3, and it moved down 5. I'm going to add this. You don't have to graph it, but this red graph, that's similar to what the parent would look like. So the second graph is skinnier, or it stretches. I didn't plot that exactly, so. All right, last step, and then we'll do another one. Is to tell me your domain and range. So take a minute and try to answer it, because we have time. How often do we have time? We actually have time. We pushed our test back, so this is a chance to, and this test is going to be out of 100, so it can really bring your grade up a lot if you do well. So what do you think your domain is going to be? All real numbers, because remember I said there's only one that does not have that domain. So if you don't get nothing else right, you should get domain right. Okay, your range, though, is not all real numbers because this graph has 2 arrows pointing up. So it doesn't go down forever. So anybody want to raise your hand and give me what you think, what would you write on the test for your domain? Aiden?
I'd say the bracket on -5 for insanity.
Okay, I agree. Who agrees? That's exactly what you should have. So this is your domain, that's your range, and we have our graph. Any questions about this h of x function? Okay. Let's look at example 4. J of x equals 1/2 times the square root of x minus 1. Try to do it by yourself. Same steps though. Identify A, H, and K. We'll do that part. Just A, H, and K part together. What is A? Looking at your pink sheet, look to see where is A. Where can you find A in the square root function? It's in the front of the square root. So what number do you have in front of the square root? 1/2. So what's that going to make our graph do? Compress. Now H for a square root is under the square root. And you still flip the sign. So that says x minus 1. So what would H be? Positive 1. And what's that going to make the graph do? Right 1. Now K is the tricky one. What do you think the K value is? It's 0. There's an invisible plus 0 back there. All right, so I'm going to give you all a minute. Get your parent table out. Apply your transformations and graph it. It's the same steps. Identify your parent table, apply your transformations, graph it. So for a square root, the parent table is 0, 1, 4, 9, 0, 1, 0, 1, 2, 3. And it's because we are being intentional. We could use 0, 1, 2, but the square root of 1 is 1, but the square root of 2 is 1.4. So no one wants to deal with a decimal in the beginning. So this is just a basic transformation table to use. So when we apply h, that means we're adding 1. For our y values, we're multiplying them by 1/2 and adding 0. So my new table that we're actually going to graph is 1, 2, 5, 10. And then you should have 0, 1.5. Wait, is that right? No, not 1.5. Just 1/2. And then 1 and 1.5. All right, who had that? Okay, so now we're ready to graph it. So x is 1, y is 0. And then x is 2, we go up 1/2. Let me zoom in real quick. And then for 5, we go up 1. 3, 4, 5. And then for 10, we go up 1.5. 6, 7, 8, 9, 10, 1.5. So it's gradually increasing. Because of that 1/2, the 1/2 is stopping it from going up. Rapidly. So let's talk about domain and range, because this one is the tricky one. You had a graph like this on the test, on the quiz, I think, where you had to state the domain and range. So looking at your x values, what is the smallest x value? 1. You can see that from the table, or you can see it from the graph. So your domain would be 1 to infinity. What's the smallest y value? Nope. The smallest y value is what? 0. Looking here. You can look at your graph. Notice at the graph that this point is at y equals 0. Notice when you look at the table that your first point is y equals 0. And are the numbers getting bigger than 0 or smaller than 0? The y values. So that would be 0 to infinity. Okay, we're going to pick up here tomorrow. Go ahead and use this time to start on your homework, get your questions answered. I am available today during A and B for an appointment.